Welcome everyone to this observable lightning talks of November. So we are live again, and if you follow recently, I scheduled another live that will be available on December. It's going to be a Christmas special edition with three speakers. You will see. So check it out. If you want to have more information, check the details of this live. It will be available. It's already available in YouTube and also in LinkedIn. So first of all, welcome. And if you're not familiar to the Observable Lightning Talks, it's a live stream that I try to schedule about every 3 months, every quarter. And the idea is to hear from thought leader speakers and people working in industry on different topics. So usually we cover in this live stream Kubernetes related topics or security topics or SRE or of course Open Telemetry, observability related. And today it's going to be in this November edition, we're going to focus mainly on observability side and also in this security side. So we'll see, it's going to be very interesting. And I'm very happy to get three amazing speakers, and I will reveal soon the agenda. So if you have never been connected to an Observable Lightning Talks, let me briefly explain the workflow. It's very simple. We will have 3 Lightning Talks, so 3 times 15 minutes. And because the 15 minutes presentation is quite short, we won't include any Q&A during those talks, which means if you have any questions, note them down or just drop the questions in your question, depending on the platform. If you connect on YouTube, you can drop a comment. In LinkedIn, same thing. From Twitch, same thing. And normally we will see those questions coming in and we will answer those at the end of this live stream, because at the end we have a specific section called the panel discussion, where I take advantage of that time to ask my questions. And if you have any of your own questions, I will try to bring them as well, so the speakers can answer to your questions. So it's going to be about an hour 20 minutes or so of this live stream. So take a coffee, some water, whatever, but be focused, because you have 15 minutes, 3 times 15 minutes to learn something really interesting. So what is the agenda of today's live stream? Well, today we have 3 great speakers that will be covering, like I said, topics about observability and or security. So we'll start with Pini. Pini is I met Pini in KCD Munich, by the way, and he's pretty much involved in the sustainability world. And if you listen on what happens on the sustainability world, there is an exporter called Kepler that provides some estimations on the usage. And Pini is going to talk about another project that he's working on. And I think I'm very excited to see it, because it's one of the topics that I really like. Second speaker will be Chris Larsen. Chris is from Netflix. He's an observability engineer working at Netflix, and he's also part of a working group from the Tag Observability that tries to unify a query language for all those platforms. I think it's very exciting, and I'm really eager to hear about the journey that Netflix went through in their observability stack. And you'll see that the query language is obviously a mandatory part for Netflix as well. And last, we will have Nick. So Nick, I met Nick several times and several of his gigs. And now he's recently working from Authorize. So and I discovered he is a solution authorized at KCD Munich. Very excited. So we see if you're dealing with RBAC policies or network policies in your cluster and you're struggling, you'll see that it's going to be very interesting to hear from Nick. He will reveal a lot of interesting things. All right. So if you are ready, I suggest that we start with the first speaker, which is going to be Pini. Hi, Pini. How are you?
Good. Thank you for inviting me.
So where are you connected from?
I'm from Amsterdam, actually just outside of Amsterdam. So it's 6 p.m. for me.
Same time as me. Same time as European Paris time or Amsterdam time or Berlin time, whatever you name it.
All the same, yeah.
All right. So I suggest that I'll leave you 15 minutes on stage to present your solution. And again, I'm very excited to see Aether. I think it's Aether, the product.
Yes.
So very excited to hear about it. And I probably have already some questions, but I will leave them for the panel discussion.
Let's see how
All
it
right.
goes. Yeah.
Yeah.
Thank you.
So see you in a few minutes.
So, hello everyone. Either good afternoon, evening, or morning, depending where you are connecting from. I'm going to talk about Aether and a bit about myself. So I'm a co-founder and CEO of Reznik. The company is called Reznik. So the whole point of Reznik was to basically move from implementing cloud native on scale. So in the past, I was co-founder of Container Solutions, which was a consultancy implementing cloud native at scale. And then we moved to create Reznik to basically solve the sustainability issues. And as we were working on it, Aether became sort of a journey to solve the sustainability or to help solving sustainability challenges in IT. So first, do we actually have sustainability problem in IT? Does IT contribute to carbon emissions? And without going into too much detail, there is a very long story about it. But in a short version, IT contributes anywhere between 4 to 5% already of the carbon emissions of the world, which is almost double of the airline industry. So we are contributing a lot, actually. And if we do nothing and the trend continues, then it's going to be about 14 or even more percent of the global emissions. So there is quite significant contribution. And what's happening now is the main challenges in sustainability in IT is actually mostly around observability. So there is not enough information. There is no right or wrong way or even reasonable way to measure emissions. And everything is focused currently on reporting, not really on reduction of emissions. So we also need to consider that when we say emissions, we don't just mean the energy consumed by the servers, but it's also the servers themselves, the energy to cool the data centers, the trucks to bring the data centers in, and a lot of different other things. So we really need to consider the entire impact, right? So including what's called scope 1, 2, and 3, so direct emissions, energy consumption, and embodied carbon. So for that, looking more into specifically now IT, so there is an organization called Green Software Foundation, a foundation which is part of Linux Foundation, which is sister foundation to CNCF. And they defined quite few principles about sustainability in IT. So basically, there are three things we need to consider when we try to reduce carbon emissions. The first one is energy efficiency. This one is quite obvious. The data centers consume large amounts of energy, so we need to make sure that we reduce that. We make our servers efficient, and we also run less stuff that we don't need to run. The second one is hardware efficiency, meaning we don't need to buy new hardware if we don't have to, right? So every time we buy a piece of hardware, there is embodied carbon in that piece of hardware, which is the emissions that were generated or emitted while producing that thing. And then carbon awareness, which is where we consume this energy. I'll talk about this a bit later. So GSF, they also define this formula, basically. SCI is all those combined. So this is a single number, but if you can calculate it, then you can know what is the intensity, carbon intensity of your software. The problem is once we went into this and started sort of try to figure out how to actually calculate it, we didn't find much. The one project that if you search for solution for this, the one project that you find, probably the first, is Cloud Carbon Footprint that was originally developed by ThoughtWorks, which is a great project. It was at some point probably the only project available around this to calculate emissions of large IT systems on a cloud. The problem is it calculates them based on cost, based on spend. I spent €1,000 on AWS, and there's some sort of average. It's not exactly that simple, but it's mostly focused on spend, which is very inaccurate, and it also doesn't really give you insight into details of where you can actually, as a developer, as an engineer, how you can reduce the emissions. So we thought there are better ways. Definitely a better way is Kepler. Kepler is something that connects to Kubernetes. It's specifically for Kubernetes. It connects to Kubernetes internals and extracts the data and has internal engine to calculate the emissions. This one is accurate and consumption-based, actual consumption of resources. It's really good, but it's only for Kubernetes. Another one is Scaphandra, which is really good also, but it's only for physical hardware because it connects directly to RRDTool protocol, which is on the motherboard of physical servers, and it extracts this data. This is even more accurate, but the problem is you have to be on that physical hardware, which in the cloud, obviously, you don't have access to. So then eventually what we chose to do is to build our own project, which is called Aether. You can find it on aether.green. And the general idea, it connects to the cloud, currently to Amazon and Google, and it brings external data from external database that I will mention, and it generates the reporting. That's roughly how it looks in Grafana. So it's very detailed. It's per instance, per VM, per container, all different things. It's currently measuring CPU and memory. And later on, it can also measure other things. So what it does, it consumes the database from a company called TEEDS datasets. So they have datasets to basically, they collected all the information about different clouds and different pieces of hardware in the cloud, and they have very detailed estimation of consumption of each of those VMs or containers in the cloud. Now, this is still, this is very useful, but it is still very much depends on our understanding what is running on the physical server, not just in the VM, because the resources, those physical resources are shared across different VMs. This is something that obviously no one can do except the actual cloud vendor. And it is actually quite important because there is this principle of energy proportionality that actually the energy consumption very much depends on what's the utilization of actual server. So the optimal utilization is typically 70 to 90%. That's where the energy consumption per unit of compute is the lowest. So once we get this information of energy consumption for each resource for a period of time, then we need to calculate the actual emissions. So the first step is to actually add all non-compute energy consumption, which is in data centers, it's called BUE. This is an example of scale where they actually expose this BUE. In this case, at two different data centers, it's either 1.48 or 1.13. 148 is good. 113 is amazing. It's one of the best data centers available. What it means is that this is the ratio of compute energy consumption versus everything else around it. So 1.13 is an amazing ratio. That means that that data center is super green. And on top of that, we need to consider how green the energy in the grid is. So this is called electricity maps. That gives us the estimation of how much emission per kilowatt hour that grid generates. Some grids like Poland are very dirty, and some like Nordics are very green. And in addition, the last point is the embodied carbon. So each one of those physical servers has embodied carbon, something like 7,000 kilograms, 7 tons of CO2. For example, it needs to be spread and amortized across number of years it serves, and so some sort of calculation around that. So basically, that's what Aether does. It goes it connects to Prometheus. Behind the Prometheus could be anything that actually consumes resources. It calculates the slots of resource consumption, then goes to its database to calculate the energy consumption. Then it goes to it converts it to emissions through either BUE and actually both BUE of the data centers and electricity map, and eventually you get the numbers around actual emissions per minute or per second per instance of VM or something like that. So this is not the only tool. There are other tools available in the market like Agnostic Kit. They are also doing similar thing, although this one is for Kubernetes. I know there's a lot of other tools. The reason we built Aether, mostly because we couldn't find anything that would do it relatively accurately in real time and not based on spend, but based on actual consumption, because we wanted to use it to actually do proper reduction, not accounting, but reduction of carbon emissions. And just very quickly is that at the end, what we find now is that anywhere between 50 to 70% of carbon emissions can be reduced without going into re-architecture or anything significant, but just by shutting down unused resources, removing zombies, removing test environments, right scaling, using the minimum needed amount of resources, and just not sort of like when you leave the room, switch off the lights, right? Just by doing that on the scale of entire business, you can save at least 50% of your cloud capacity, which includes both emissions and cost. And the last part is that we basically, the reason we built Aether is to consume this data by Reznik platform, which actually calculates emissions from different sources. So in this case, this is the infrastructure. So you can see there's actual consumption in kilogram or grams of carbon emissions per slot of time. Then we can get recommendations like, for example, reduce the emissions by right scaling your VM because it's over provision, it's not in use. We can also collect this information from buildings that are digitalized, or even from physical trucks, because modern trucks also have some sort of telemetry. Right, so the idea is to collect this information from different sources that are digitalized and present it in the way that is like observability, right? So that's something that is practical for engineers to act on. This is the critical difference between the reporting, which only cares about presenting it to the regulator. What we really want to achieve is something that can show the information in the way that that is actionable for the engineers, for people on the ground. So if you want to read more about the actual methodology or details of Aether, or do anything, contribute to it or use it, you can go to aether.green, and you will find there links to the blog post that defines or describes the methodology and tells more about this project. So, and please ask questions when you are ready. At the end, obviously.
Correct. Thanks, Pini. So I have some questions, but I'll keep it for at the end of the session. I had a question about Aether and also a couple of other things. You mentioned logistics, and it just forgot that point every time I talk about sustainability. I forgot about the indirect consumption. So it's a good point to remind it for sure. All right. So thanks, Pini, and I think let's move to the second speaker, which is Chris. Hi, Chris. How are you?
I'm awake. How are you doing?
What time is it?
9 o'clock back in California, in Silicon Valley.
So it's not too early. It's almost coffee time, almost.
I drank my first cup, so
so you're gonna get it later on. Chris is, like mentioned before, is working at Netflix, but he's also part of this working group that has been available at the observability, where there's an initiative to unify a query language, because as if you're using any observability solutions of the market, each individual solution has its own query language. So PromQL, in the case of Dynatrace, it's going to be DQL, and every time you use another solution, you have to learn that query language, and sometimes it can be quite frustrating to keep to just be maintaining and upgrading your dashboard depending on which backend you're referring to. So I think it's a great initiative, and I think the best way to learn about it is to listen to your talk track. So I will give you 15 minutes and see you in 15 minutes, in fact.
Great. Well, thanks for having me. So my name's Chris Larsen. I'm an observability engineer at Netflix currently. Previously, I was at Yahoo. I've been working in the space for quite a while. So today I want to talk about kind of the story of Netflix and our observability systems there and why we needed to look at a new query language. So as most folks are likely familiar, we started off by mailing DVDs out. Tons and tons of red envelopes have been sent over the post over the years. Eventually, we added a recommendation service analyzing what users watched before and liked and tried to figure out what they might like later. This was kind of early on the internet, and it brought new infrastructure that we had to observe. Later on, we started streaming, which is a lot more involved infrastructure-wise. While CDNs took on kind of the bulk of the actual media feeds, we needed to handle encoding, distribution, monitoring of the assets and the website. And then once Open Connect was launched, which is our CDN ourselves, where we embed appliances and ISP data centers as close to the end user as possible, we had thousands of new instances to monitor across the globe. And then, of course, when we started producing our own content, we needed to support studio operations. So all of the directors and production folks who needed to deal with scheduling and acting and scripts and whatnot. Now at over 200 million members, we have streaming across the globe, and we have some awesome SREs who have been responsible for maintaining one of the most reliable streaming services on the planet. But of course, no business remains a business without changing, as we've seen. So now we're dealing with VOD, video on demand, as our focus, but we're branching out into live events. There's a big Mike Tyson fight coming up soon, an NFL game at Christmas time. Should be interesting. We're also dealing with gaming, where users can play different mobile games with their subscription. And of course, behind the scenes, we have lots of AI and ML. And like it or love it, we do have advertising now to bring down the cost to subscribers. So all of that entails observability needing to evolve with the rest of the company. So starting out with observability journey, it's pretty similar to what everybody else has encountered in the industry if you've been working for a long time. We started off with bare metal hardware and an Oracle database where servers would write their metrics into it. Alerts would query the database periodically to see if anything was out of whack. And then devs had to SSH into hosts to look at logs or other details. Then famously, AWS or Netflix was one of the big companies to migrate everything to AWS. At that time, to keep some load off of the Oracle DB, we moved metrics into RRD files spread across the various EC2 instances. And now we had SREs dedicated to making sure Netflix was stable. So they started using the observability system. When metrics volumes grew too large, we went and rewrote the metric store as an in-memory key value tag metric system called Atlas. It's open source. Anybody can take a look at it. A few people are using it externally. But the observability team managed it for the whole company. Meanwhile, teams were sick of logging into their instances to look at logs. Instances would disappear and the logs would disappear with them. So they started storing it in elk stacks and using different vendors at this time. Also, from consumption standpoint, Canary started querying the data to gate releases of code, and auto-remediation frameworks looked at metrics in order to terminate bad EC2 instances or containers. Then, when alerts and automated systems grew to the point that querying Atlas impacted performance of the DB, we created a streaming system to push real-time data out for those use cases, and that took a lot of load off. Next, we brought in distributed tracing, which makes it really easy to diagnose issues with the thousands of microservices that participate in any request to view Netflix content. And similar to logs, we started off with Elasticsearch and various vendor tools to handle that, but it was still decentralized. Of course, it's a pain to manage your own elk stack or vendors, so we started consolidating logging and tracing centrally. So we took that over using Iceberg and Cassandra and Elastic too, and now we have logs and traces centrally. At the same time, we noticed that more and more users were accessing this data. So we had data science folks, business side, capacity planners, the ISPs themselves were looking at metrics for their OpenConnect appliances. Managers were looking at even customer service. So all of this led to, a Byzantine messy stack that we needed to deal with. So with 9 engineers on our side, just handling all this instrumentation, ingress, and storage, we needed something a little bit simpler. So big surprise, we're following the industry trend of moving as much data as we could onto object storage. So a number of vendors have succeeded with this approach, but because of our volume of telemetry, we can't pay for that. So we have to do something ourselves, roll our own, and continue evaluating what's out there. So it's a typical architecture. We ingest the telemetry data, the various types, and we flush it S3 as quickly as we can. We also compute dynamic indices, automatically choosing the proper index structure to use. And then while the data is still schemaless, users can send any attribute they want. We still index as much of that data as possible. We store it in S3, load it in caches, and then a query service will query that data and spin up lambdas if the load is big enough that we need to spin it off separately to support a big query. Our initial target has been tracing data. It saved us about 30% of the cost versus our previous Cassandra and Elasticsearch system. The average query latency has actually decreased a bit, which is really nice, but tail latencies did grow a bit. The next step is going to be logging because that's a natural permutation for us. And then we'll work on metrics. That's kind of the trickiest part to get right because people are used to really efficient and quick queries, sub 500 millisecond queries on the majority of their queries. So there are benefits we still have moving to this that we need to enumerate, but we also have challenges. The biggest benefit, of course, is cost. So when you look at observability data, you apply the 80-20 rule or maybe 90-10 rule, where very little observability data is actually queried after storage. So if we can store it somewhere that's the cheapest as possible, that's great. Reducing our spend lets us maintain more data that may eventually be used instead of writing rules to drop it all. And it turns out with AI, more data is being used, particularly in the security realm, where people are just scanning massive reams of data offline and gaining insights from that. So what do we get as developers? For 9 of us, we have a nice shared code base and common patterns and infrastructure, and we all know the system, so it's easier to handle on call versus having folks deal with Iceberg or Elasticsearch and tuning all of these different products. For the users, they have fewer products to learn from their side, and that we can unify all of these under different APIs or a single API and UI. They also have lower telemetry costs, and they have less concern about cardinality or writing rules to drop data they don't want to pay for. Also, on this auto scaling on the query side, helps improve query performance consistency. Another benefit, of course, is that users have the ability to analyze metrics, logs, and traces, and eventually profiles in the same query. However, making this possible, it's really critical that users use consistent attributes on their tags. So For us, for central observability, our telemetry clients have imposed standards for a long time where we use the same tag names and dimensions so that you can join the data. If you haven't standardized yet, I highly recommend using the Open Telemetry Semantics Convention that was donated by Elastic, I think, a year or two ago. If you have that tagging and attribute consistency, it makes life a lot easier. So one example of this is that when we pull up traces in our Edgar product, you can see the associated log lines and errors with that. And we intentionally keep our log data separately from traces because traces in our system involve thousands of spans, hundreds to thousands. In the case of batch, we'll be up to millions of spans per trace. So it's important to do that join when it's needed. Likewise, for viewing metrics, you're able to jump to logs or other telemetry types easily when you have some commonalities there. And a question that comes up along with this, putting all this data into a data lake like that, is why not just go with white events? Well, some vendors are able to do that for smaller scale use cases, and even some massive companies have done that. The drawback is that white events are costly and that you need to allocate resources, record, serialize, and transmit every single event. So at a small scale, you can do that. You can store it and then write queries at query time to extract useful information. That works pretty well. But at a large scale, you have to have excess processing bandwidth just to transmit the events. And then you have to figure out somewhere where you're going to write rules to extract useful information. And for us, for companies in the middle here, it just doesn't really work. And it really just winds up shifting, I think, the burden of developers to extract information to the right, to query time. Challenge that we have, of course, with our system coming up to DSL or domain specific language is querying. So here's an example of a query in Atlas stack language that we have. It's from one of our SREs who came from a popular observability vendor, and this computes an SLO and violations and even highlights violations of that SLO. It works, but it's ugly. It's a stack language, RPN. It's different from what majority of users are used to. And while it's powerful and has great analytical capabilities and even presentation abilities, users who are familiar with other tools coming in Netflix, other tools like Prometheus, Splunk, or Elastic, they hate it. So we wanted to figure out what everyone else is doing. Well, every observability system out there has their own DSL. And why is it? It's because people were trying to create a syntax that is really easy for SREs or DevOps to slice and dice in the heat of an outage really quickly to figure out what's going on. There's also been a lot of work to build useful GUIs that hide syntax from developers and users completely. So instead of creating a new DSL for us internally, we decided to reach out to industry, kind of survey all of these and see if there's any commonality or consensus we could reach on a query language. So the OTel folks wanted to do this in OTel, but OTel specifically focused on telemetry. So we joined with the tag observability group in the CNCF to do the semantic research to recommend a semantic standard. And we're picking semantics initially because syntax is going to be really difficult. That's going to be a ton of bike shedding and arguing over about, is white space better or colons or, pipes, whatnot. So if you want to get involved, please join us, search for the CNCF observability tag or look at the link we'll have here later. And we do have a feature rubric that's out that we're looking for comments on, and we're also looking for a presentation from the Google Observability team next week regarding piped SQL. There are also a lot of personas that we have to evaluate when looking at the DSLs. Traditionally, as SREs who need to look at data quickly, but now more and more users are getting involved, like DevOps. So now developers have to deal with the observability language or the systems, and they may prefer a GUI as opposed to dealing with query languages. Platform library owners are creating dashboards and alerts for their users, so they also want to use something simple. But the big thing that's happening in the industry right now, I might talk about it later on, probably next week too at the query language meetup, is that more and more data scientists and BI users are getting into the observability space where they need to join observability data with existing BI data. So it looks like everything is really merging together. And so we need to get out of the mindset where we think observability data is in its own silo, and really think about how we can work with other telemetry types. So with that, I'm almost at the end of time. I'll leave it there, and I want to thank you all for the time to present, and look forward to chatting after the next presentation.
All right, thanks, Chris. I saw a lot of things on the diagram, and I had a few questions. I will keep that for later. But it was really interesting to see the actual journey that Netflix went through, and I really like the fact that you highlighted the fact that observability is not only like a SRE infrastructure thing anymore. There is so many people that could take advantage of the data that are stored in their systems. So I agree. Having a DSL that is easy to use and easy to learn is required if we want to have be able to have a larger adoptions within organizations to not only techie people but also marketing or other type of services that could be interested on the data. All right, so let's move on to the next speaker of tonight, the last speaker, in fact, of tonight. So see you guys in a few seconds. Hey, Nick, how are you?
Hello. I'm very good. Very happy to be here.
So
as usual.
Connected from London, UK, or
Cambridge in the UK.
Cambridge. Ah, yes,
Which more north.
You mentioned that several times. I always forget.
North.
So how are things going? So you will be at KubeCon next week, I guess.
Yeah, flying out on Monday, but still have a busy weekend. I'm running a 10K race on Sunday in close to Heathrow, and then I just barely have time to recover, and then.
So basically, you're going to run once you've crossed the finish line, grab your luggage, run to the airport, and take take a shower for the rest of the flight, for the rest of the attendees in the flight. It will be.
Yeah, exactly. I'm really looking forward to running in Salt Lake City. I love to discover cities by running. I think this is awesome to do because it gives you like another perspective on various cities.
I agree.
Love that.
And specifically, we usually run on the morning, so then you discover the city in completely different.
Yeah, and the thing is, I'm not really an early morning person, but because of the jet lag, it's a lot easier.
Yeah, of course. So for those who never heard about Nick, so Nick has been he joined Authorized last year or something like this.
I was back in April this year.
Yeah. So yeah. Oh, sorry, last year. So almost.
Yeah,
almost. Yeah. And so for those who never heard of Authorized is a really interesting product. So it's open source and also they have a commercial solution. But if you are struggling with configuring your policies in your cluster, then meaning the service accounts, the secrets, and all the things that you need to pay attention when you deal with security, Authorize is taking this and managing it for you in a smart way. So I will leave Nick present it. So I think he will probably present it better than I just did.
I'll try to.
So see you in 50 minutes then.
Okay, cool. Thank you, Henrik. So yeah, today I'm going to talk about the quest to build a unifying framework for workload IAM. And really the goal is to think about how we can make a better job to deploy and enforce security and making it a team effort between the security team, developers, and platform engineering. Because usually this is where things get a bit stuck, between this team. So a bit more about me. So my name is Nick. I'm the head of developer relations at Authorize. I've been working with Kubernetes probably about the past 7 years in different capacity, working on different area of the project, CNI, so networking, CSI, storage, edge, security, Kubernetes management, all that. In my day-to-day job, I love to do demo stuff, but by coding fun apps. And actually today I'm going to try to get all the 15 minutes, some demos in. Hopefully it should be fun. On top of that, as you could have guessed, I'm an avid distance runner. So if you want to connect with me, you can try LinkedIn, but where I'm the most probably connected, the most active would be Strava for sure. Okay, so at Authorize, as Henrik said, we simplify and automate access policies for workloads in the context of cloud native and distributed or highly distributed application, with the idea of making the life easier for developers, for platform engineering, and for security team all together, for those teams to be aligned and fast when it comes to identity and access management. So the example I like to take is if you think about the gaming industry, or let's say the mobile gaming industry, or actually the mobile industry as a developer, what I find is great. If you need to use some special capabilities of the device, then you can specify here as an example into an plist file for Apple for iOS, and you just define at high level in a very declarative way what capabilities you need to make your program or your game or whatever you do work. And at Authorize, we want to build basically the same kind of thing, except that this time, instead of having a device list of capabilities, we want to have a list of calls between services. So you have service A, service B, service C. You have specific application, maybe Kafka, maybe a database. You may be using AWS or any cloud and some sort of IAM. You may be using network policies, Istio, all of that. So the idea is to build an abstraction layer to make it possible for developers to very easily specify their requirements between their application. Second, to be able to apply things like or principles like GitOps, so that it gets easier for the platform team to maintain, deploy in different, in productions or in other stages, but also make it more dynamic by giving the ability to monitor the traffic and have this least privilege principle with zero trust in mind, using monitoring techniques so that we can discover what's the actual traffic is and what actual policies are needed for the application to work and being the most secured. So to do this, we have created this innovative concept of IBAC, or intent-based access control. And the idea is exactly that. So you have an example here on the right where the resource to make IBAC possible is called a client intent. So probably you may have guessed it. Client intents is a YAML resource actually using a Kubernetes operators. It's a custom resource in Kubernetes, and it's client focused. So let's say if you have service A wants to talk to service B, or here on the right, like the checkout service, excuse me, want to talk to the email service. Well, you just specify the name. Then we have techniques to identify the services, or you can customize and flag services. I want to call it this way, but we also have way to dynamically and automatically identify services. And then depending on the lower level security where your application is running, then we can automate different things. So I'll give you an example here where you have an analysis service who wants to talk to a database. And this is two services running in Kubernetes. And we also have the database integration in Authorize. So here is an example of a client intent you could use to configure least privileges and securities. So the first part, where you basically want the analysis service reach the database from a network perspective. So remember, it's running in Kubernetes, which means that you are specifically targeting CNI and network policies. So the only thing you need is a CNI that is compliant with, that can enforce network policy. Not all of them can do it, but 90% of them. So, and to do that, so here again, we are in focused from the point of view, the angle of the calling service, client intent. So the client service is analysis. I want to call, so this is what you see here, name analysis. I want to call DB, right? First line, this is going to automate network policies. And then if you don't specify any type. Second, because we have this database integration, then we can specify another type. So type database. So this is where it's getting a bit more interesting, with this idea of multi-layer security. We have the network security. How about the application layer? So we are running a database here. So we support today SQL, Postgres, and Cloud SQL as well. So again, you specify type database, the name of the database you want to secure, and you can go also per table. If you omit table, it's going to be valid for the entire database. And then you can specify the list of operations that you want to allow between the analysis service and the database itself. So you can do it manually, like create manually this file, type this file, or you can let the system detect the right operations that are needed for the application to work. So you deploy, the idea is you deploy the application, you just leave the application there, use the application, and we're going to catch all the traffic, and we're going to make it dynamically. We're going to suggest what type of client intents you should apply for that particular application, right? So that's one of the example. And here, this is a resulting network policy. So you don't create that. It's the system that will create it for you. We will create the right labels, and we will apply the right labels on your workloads as well. So here, this is ingress. We can do egress as well. And here, this is for the database. We will create a specific secret with username and password for the database. And then on the database itself, we're going to create a particular user with the corresponding operation that are allowed. And then the only thing that is remaining from a developer perspective is that you have to use that secret from the container, right? So you call out that secret and you use that particular credential file to realize your operations on the database. So here is an example a bit more complex where you have Kubernetes microservices, Redis, a cache, NATS, message queuing. You have external call to the internet, and also you have a serverless database this time. So the calling service we want to focus on is joke worker. This is a dad jokes generator. I'm going to see an example in a demo in 1 minute. And the idea here is exactly the same from a joke worker perspective. So you specify joke worker. Then I want to call Redis, simply, no additional type. This is going to be network policy. Same thing with NATS. Then you want to connect to AWS. So you need two things. You need to specify the resource you want to connect to. So here, this is the identification, the identity of your specific Dynamo database and table. So type AWS and the type of action. So here, by practice, I've put a wildcard for simplicity, but normally it should be a list of permissions, right? And again, we can detect the least privileges permissions you need to make your application work and guarantee security, like self-documentation, if you wish. And then last but not least, you also need to connect to the internet. So we can also detect the domain names you're going to connect to. So here, STS for the token, DynamoDB for the application itself, and OpenAI API, because this is how the jokes are generated. So you apply this, and again, everything is going to be configured for you. And this is what I'm going to demo in a minute. And also with Istio, so layer 7 sort of policies, security policies, same principle. We have an online shop with the front end that needs to access order, cart, and product. Here, we can again detect the calls. That's Istio, because you have Istio installed, you enable the metrics on Envoy. And based on what is logged in Envoy, we will recommend the least privilege permissions, you need to access the service. So here it's a get on /order, here a get on /cart in terms of the HTTP resource, and here a get on /product. So again, you apply this, and it's going to create both network policies as well as Istio authorization policy. So again, this notion of multi-layered security. Hopefully that makes sense. So let me jump into the demo just for 5 minutes. So I'm going to do this access graph. And let's go back here into the command line. So here on the left, this is exactly the application I've mentioned around, so this is online sort of shops microservices where you have the front end that needs to talk to products, cart, and order. This is the application here on the right. So I can just go to namespace online shop. And actually, it's kind of simulation where the online shop, the front end, is just coding out the other services. So the application is installed. I've installed authorize, and that front end is just calling, in a loop, all of the services. So basically, what I'm doing, I'm generating traffic to show you how the intent are generated. So if I go back to the cluster, entire cluster, this is the authorized solution, couple of operators, as well as a sniffer. So the first thing I can do, so this is from the cloud portal. You can go on the portal and create an account, totally free. The solution itself is open source, of course. There is a CLI I'm going to show you as well, but of course the let's say the SaaS portal will give you more visibility, more integration, these kind of things. So here, if I just click again here, let's do it this way. So you can see I've clicked the client, and automatically here on the right, because I'm generating the traffic, we are observing the traffic and saying that, okay, this is seen in discovered traffic, but not declared in client intent. So what that means is that to make the application work, I need to apply this client intent. And you can see here, I'm assuming default deny. So which means that this is why I've got the red line. So it's assuming, meaning that currently the application is working. I didn't apply any default deny, right? I'm just assuming. It's like in learning mode. I want to know what is going to happen if I were to apply a default deny. So obviously, I don't have any network policies. I don't have any client intent here. Everything is empty. Network policy is also empty. Authorization policies empty as well. So the second thing I can do, I can download this. So I can download this or copy paste, or I can also use the authorize CLI to do that. So authorize mapper, I can export. I can also generate, picture and stuff like that, or I can just export the YAML, right? And once it's there, the only remaining part is, of course, you can pipe it to kubectl apply, so that is going to be applied into the cluster. So if I go back here into client intent, I apply this. Okay, so you can see that it's been applied to the cluster, and I've got the same content. And now, interestingly enough, if I go to network policies, I would see the different network policies created. First, networking layer with the right labels. And if I go again in authorization policies, Istio, the same thing. And if I go into this YAML, you can see that now I'm going to layer 7, and I'm bound to the service account from the front end, from an identity perspective. So we can also automate certificate management and MTLS as well. You don't necessarily need Istio for that, but we can automate it. And you can see the operation, the method, the path, the same kind of labeling that happens on the network policy side. So that concludes what I wanted to show you today. So we've seen in particular how we can automate network policies in Kubernetes. We've seen Istio, layer 7. We've seen databases, IAM policies as well in the cloud. And we also have more, but I think for today, that would be good enough.
All right. I was watching the time, and I say, should I interrupt him or not? And but it was good. It was good. So for those who wants to get more details, there's the QR code here with the authorized Slack. If you want to join their authorized Slack channel, and there's also, of course, the actual QR code to get to the authorized web UI that Nick showed you a few minutes ago. That allow you to have a graphical way of seeing things and configuring things. All right, so I think thanks, Nick, for this talk, and let's jump into the panel discussion. So see you guys in a few seconds. Awesome. So first, thanks all of you for taking the time on presenting and building slides and sharing the various concept that has been presented today. So I think it's very useful, and it requires investment for your end. So thanks for taking the time. So I have a couple of questions, and of course, like discussed, if you also have questions. If you had questions, for those who's listening, drop your questions in LinkedIn, Twitter. No, not Twitter. It's X, but they don't do streaming, or you have to pay for that. But so YouTube, LinkedIn, Twitch, or yeah, that's it. So if you have any questions, drop your questions there. Otherwise, I have my own questions, and maybe you also noted questions for the other speakers when listening to the other talk track. So let's start with the first speaking session, which was Pini. So Pini, I think I really liked the presentation. I had two questions, in fact. One was related to the Aether, and you said that is able to get metrics from any Prometheus that could push any metrics of resource usage. And then I had when you showed the data center. Of course, if I pick Frankfurt or Poland, you mentioned that the grid will be the energy produced is less green than other regions of the world. So do you also consider, for example, okay, so this is a cluster running, I don't know, in Europe West 3 or whatever that corresponds to Paris, for example. So then the carbon emission is different from a data center that would be in Frankfurt or something like this. So how do you, so does Aether require like a connection to your cloud provider to get that type of details, or how does it work?
So actually, every data center has the BUE. So this is the factor of energy consumption for basically data center efficiency. You don't always get this. I think you can get this for Amazon and other major data centers, but it's relatively rare. So it's static number that they publish once in a while. For others, like Scaleway in France, you can get it from API, so you can actually measure in specific time. But that only gives you the energy, right? So it's basically the energy consumed by your infrastructure plus the energy consumed by the data center around the infrastructure. Then you need to actually take it to something like electricity maps, which actually, so you need to understand where the data center is. That's something you know, right? Because if it's Frankfurt, it's Frankfurt. Then you go to electricity map, and that will give you the carbon intensity of the grid. Now, it's not exactly correct, right? Because most major data centers would have their own sources of electricity, like solar or alternatively, actually, diesel generators. So it's not that simple, but we try to get as close to consistency as possible, right? But basically, from energy to get the carbon intensity or carbon emissions, you need to go to something like electricity map that converts it from energy to emissions based on the current state of grid.
But the Aether is able to do that, or
Yes.
you have to take that.
No, we actually do the calculation, right? So we actually go and connect to electricity map. We do all the collections together. So basically extract the consumption data from Prometheus and go to TEEDS database to calculate the energy, then take it to electricity map for emissions plus the embodied carbon, which is the hardware. the
Yeah.
physical stuff. Yeah.
And then the other thing, you because you brought that topic, and I said, oh, that's something I never thought about. Is I mean, when dealing with measuring the actual energy consumption of the workload, I never considered the logistic piece in that.
Right.
And you made a good point saying that any cloud providers, they will probably provision new racks or new space in the data center. So there is like there is some trucks that load, and there is a lot of operations to do that. And also the fact that you need to cool those servers down. Is there a way that this sort of energy that is, of course, consumed by the cloud provider, do we also can have some of a portion of it? Say, oh, I'm using, let's say, 10% of the given data center. So it means that this logistics or the trucks and the cooling down of the entire is also due to me because I'm consuming a significant part of the data center.
So yes. So first, there's 3 scopes, right? The scope 1 is something you burn directly. You drive a diesel car or petrol car, and you burn actual fuel. That's direct emissions. That's scope 1, right? Or similar. Second, scope 2 is electricity you consume, and somebody burns carbon and something for generating that energy. And the scope 3 is supply chain, is everything that you're consuming, right? So if you, for example, if your software goes and uses API to do some machine learning, you need to consider that too as part of your emissions. Of course, that relies on the third party to give you those numbers, which is not typically not available. Now, what's happening in Europe, there is regulation to actually to report all those emissions, all 3 scopes. It's gradually increasing, but generally you have to report all 3 scopes. And if you go to major vendors like Amazon or Google or Azure, they will consider all 3 scopes. So when you look into their reporting, they will consider everything. I know that Amazon would consider everything up to the building itself, because also building the actual data center, there's concrete and there's other stuff. Eventually, they will have to consider absolutely everything related to emissions, and they will have to spread it across the consumption. It is challenging, though, very, very challenging, right? Because obviously there are so many factors, and they are very complicated to measure, right? Because, I mean, measuring carbon emissions of a building is not easy, right?
Yeah, of course.
Without going into details, but it's not easy.
Yeah. But yeah, I mean, but I was just thinking if as of now, those numbers are more on the cloud providers' numbers. They are not splitting those numbers within their customers. They are just saying we are consuming this, and it's not.
It includes that. So if you can, if you do, it's actually what the major providers give you is sort of good enough in the beginning. It's based on spend. It's very much average. It's not precise per unit of compute, but it gives you a general idea, and it does include all 3 scopes, at least to a certain extent.
Chris, Nick, do you have any questions for Pini on this topic?
I had one around, is Aether capable of making recommendations? So you pointed out the low-hanging fruit there, and can the tool say, okay, you should shut down this instance or this one, it's underutilized, or switch this workload from 86 to ARM?
Yeah. I think there are few. I mean, the first, the obvious one is just optimization, like hardware optimization. Well, not hardware optimization in this term. I mean, optimizing your environment and shutting down unneeded stuff, right? Over provisioning and zombies, all this is trivial. ARM is better, but it's not always obvious if the transition is worth it, right? So, but generally, ARM CPUs consume less compared to Intel. What else? GPUs are terrible, especially on scale. They're just enormously hungry for energy. The thing that typically people consider as a first step is to move geolocation, sort of follow the sun, not in a way of follow the sun SRE style, but follow the sun, actual sun, where the solar energy is available. This is actually not super helpful. It's helpful for your own reporting, because then you can reduce emissions on your report. But you're effectively moving, for example, from Netherlands to Sweden. Okay, fine, you can do that. Then your emissions are lower, but then the Sweden will stream less energy to Netherlands, and that's what doesn't help anyone, right? And what actually will happen is likely you cannot restart the entire system that quickly in Sweden, so you will maintain two setups, which actually will consume more energy and more hardware, which makes no sense at all. Right.
No, completely.
So it's like people need to think reasonably, right? What is available, like, beyond just the obvious? Yeah, okay, I use greener energy, but it may not actually help.
Nick, do you have any questions for Pini?
Yeah, quick question. So, do you have any like automation for remediation connecting to specific equipment, hardware to, maybe play with the power and things like that? Or at the moment, it's just like
I think so. There is the Kubernetes itself. I mean, there's a bunch of different tools that like kubectl or whatever. It's not precisely the same thing, right? Because you can manage cost with different means, like spot instances. They don't really contribute to reduced emissions, but they contribute to reducing cost. But effectively, there is very close correlation between cost reduction and emissions reduction to a certain extent, to the first 70% or so of reduction, right? Then you need to start making decisions where to invest to reduce emissions, right? But in the first 70%, just reducing cost almost automatically reducing emissions, almost the same ratio.
Yeah, except if you move everything to spot instances, where
that doesn't do much to it. That does a lot to cost, but then you have different challenges. Like, without going into too much argument, but that is something that doesn't affect much emissions. Actually, it's not even true. It does affect, but in much more indirect way, right? Because that allows the cloud vendors to optimize their infrastructure better, right? And shut down the environments and do all kind of things. So in this sense, it does help, but very indirect way.
Okay.
And what do you think is the most digitally polluting component? Is it
GPU, GPU, I guess.
But GPUs. So
GPU.
I think the data shows is that all three major cloud vendors were on the path to net zero around 2030. And in the last 2 or 3 years, they all grew in emissions in about 20, 30, 35%.
Wow.
All three due to AI.
No way. 30%.
Yeah, so instead of going actually to almost zero, they actually increased by 30%.
Okay.
We're far from the balance.
It is absolutely amazing the amount of energy consumed by AI. And we assume that this is just the beginning of the journey.
Yeah, and the problem is that everyone wants to have a AI feature or AI story, so everyone is investing lots of R&D effort in building that. So we are far from slowing down that.
I mean, Azure, they grew like, I think 20 to 30% in the last 2 years. They didn't show the numbers until recently, a couple of months ago, and it's all ChatGPT effectively.
Yeah.
Gosh. Okay.
It's not going to get better for the next 4 years in terms of climate
No.
efforts.
The question is, the challenge also is beyond the challenges of not getting those GPUs from NVIDIA, actually, the bigger challenge in Europe is actually getting electricity. But it's actually not available. The grids in major countries like Netherlands and Ireland and others, they cannot support any more data centers.
Greenland.
You cannot, in Ireland, you cannot connect to the grid. You're just not allowed to build new data centers because there's just not enough electricity in the grid.
Yeah. So I'm looking at the time. So let's move on to thanks, Pini, for those insights. They were interesting. I have more questions, but for the regards with the time, we need to switch session. So, Chris, I have a couple of questions. So you mentioned in your slides, I remember there was a protocol so it was like Open Telemetry, but a Netflix and a empty. I don't remember what it was the name, and I was wondering what was that protocol for? To exchange the data back to the very storage. There was a specific. So I thought, oh, it reminds me of OTLP, but maybe a Netflix proprietary protocol use, or
Oh, we still, yeah, for the vast majority of our telemetry, it's we're using open source tools. So for logging, we do Open Telemetry. So that's all transferred normally. Metrics are all custom HTTP JSON formats. And traces are Zipkin formatted, but we don't use the OTel collector for that. We use a proprietary version just for efficiency reasons.
and you said that you're using Zipkin, so you're using Open Census, or your open you moved from to Open Telemetry, or is it still traces in the Open Census format?
No, still the Zipkin 2 format, actually. Not
Okay.
every census.
Okay. And do you have any plans to move to the new to the Open Telemetry format, or for the effort will be too big, so you're keeping on Zipkin for a moment?
It's slowly we are going to be supporting the Open Telemetry format and ingestion, but we do have a lot of baked-in systems that are using the Brave libraries from Zipkin. And same with metrics. That's our system is a bit different, that we're push-based and we store everything as rates instead of counters and align everything on a step boundary, so it'd be difficult to migrate to OTel for that use case.
So you're already pre-aggregating so you don't push counters. You already do a pre-aggregation at the source before pushing it, or
Right.
Okay.
It's a lot cheaper because we don't have to worry about scraping, and when we store it, we're already storing data as vectors, so we don't have to do any
Transformation.
downstream
Yeah, to the query.
Mm-hmm.
Yeah, makes sense. And so you mentioned that at the beginning, people were adding their own attributes or their own things. Is now with the fact that everything has been moving and standardizing, now Netflix has a standardized semantic based on Open Telemetry semantic, or you have enriched the actual semantic?
We're not using it internally yet, the Open Telemetry. So that's why I recommend anybody else who's looking to migrate or standardize, they should use that. Internally, we've had our own standards for quite a while, particularly around IPC metrics, measuring communications and latency between services. We could look at moving in the future, maybe having a shim and a rewrite layer at the query side. But it's going to take a while. It's a big ship, a lot of deployed services. It's difficult to migrate here.
And last question from my end is: you had this query service, and then based on the query, it will spin up a Lambda to do some stuff. And I was wondering, so is there like a query service as like a sort of caching? Because maybe if there is like the last 30 minutes, people, if there is something they want to look at what happens now for just from an ops perspective, are you caching that the last let's say 30 50 minutes, so then the query is not reaching the data source anymore, or you still need the Lambda to get the data?
No, we still use the Lambda for the recent tracing data too. We wind up, of course, following pattern where you write every minute or so to have the most recent data in S3, and then we query that. Eventually, we roll it up with offline jobs to compress the data, merge it into smaller files. And right now, we're using Parquet, using something similar to what Tempo is doing. But we found that those recent queries, even on S3, when it's partitioned and sized properly on the S3 side, are pretty efficient.
And you mentioned logs, and when you query, you have the trace, and then you have the log. So are you adding in your logs the trace context to
Yep.
map it? Yeah. So and I was wondering, so because you said that you don't put the logs at the same, because you said that the trace was too big. So then if I am in a specific span, can I still be able to look at the log lines related to my span, or do I need to re-browse the logs itself?
Yeah, the UI does a joining right now for that. And once logs are merged into the new ODL framework, then we'll be able to issue a query and fetch the same data at the same time.
Okay, cool. And question more on for everyone listening. So usually Netflix, when they build a new solution internally. They put it open source. Is this going to be like an open source solution that will be out there, pushed by Netflix in the future, or maybe it's already there? Maybe I'm
Yeah, it's not open sourced yet. Still internal, still working on it. I think the outcome of the query language working group may have some impact on the direction we go, because we may try to merge it with other data lakes like Iceberg or something else. Or we'll spin it off just for observability.
Okay, cool. Thanks. Pini, Nick, do you have any questions to Chris?
No.
Nope.
Maybe just I used to live in Los Gatos, very close to Netflix. I remember there's a Vazona Park, right, and Los Gatos Creek Trail, which is so beautiful.
Yeah. And our author of Atlas is a big hiker, so he's been every time when he lived out here, he'd walk along it. You probably
I miss this a lot. Yeah.
Very
nice.
Very close.
And let's move on to Nick then, if there's any other questions. So Nick, first of all, thanks for your presentation.
My pleasure.
I like the fact that you did a demo, so it showcased the solution. You were so there was two things that I had in mind. I mean, so you are basically you are capturing through the sniffer. What are the endpoints? What are the layer 7 endpoints as well that is currently used, and then you configure the right client intent to authorize or not authorize specific communications. And then I also something that is also very challenging for users when they are in the security space is the security context when you need to assign specific capabilities. So should I drop all the capabilities or assign specific ones? And I was wondering, is authorize maybe in the future, or maybe it's already there, able to also identify what are the actual capabilities that is used by a given service and say, this is the one that you should use to make it secure. So make that type of suggestion as well.
So do you mean we capture every call, so we see everything?
So for me, it's more the kernel capabilities that is
kernel, okay. That's an interesting point. So today we are not Tetragon, right?
Tetragon. If you apply the right policies in Tetragon, you can get that type of details, because through eBPF you can have that. And I was wondering, because I think authorize is based on eBPF as well, no?
So, long story short, we started to use eBPF to get rid of IAM proxy live to monitor API calls. So now we have eBPF solution pretty much for everything. So which gives us a lot of possibilities. So today we are focused on compliance with the ability to detect PCI, PII traffic, and to be able to auto tag workloads, and then full environments, and then tell what is happening depending on the regulations that are involved. We're going to check like OWASP, best practices, blah, 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 and then recommend some security. Today on the network only, right? But as you said, in the future, we can go a bit deeper into syscalls and things like that. I think it really depends on what users want and what we see from the industry. We don't want to create a second Tetragon. That doesn't have
I mean, because
but from a visibility perspective, it makes sense. Yeah,
but I was thinking, because at the moment you're pre-configuring Istio CRDs or customer sources from Istio, or you're doing configuration from other aspects, and I thought,
automating Tetragon,
like being able to basically create a tracing policy, or not a tracing policy, but here it's more configuring tracing Tetragon, if there is a Tetragon plugin that say, okay, give me the capabilities, and then do the changes.
Yeah. We could integrate with Tetragon, actually, because we have the reconciliation mechanism. We have all the automation is in place. The only thing we need is for any integration is just develop the lower level part to translate the client intent into the right resource. So the possibilities are almost infinite. So it really depends on, if users come on, opens an issue, or if we have a prospect who really wants to do a particular integration, we'll do it. So today we have things like GitHub integration for automating pull requests. If we see a new call, we have Slack integration. If we see that a call is blocked in production, or a new call that is not supposed to happen in production, maybe there is a bad actor. So this is also there. So we can imagine extend this to syscalls and anything related to more like kernel Linux level for sure. And we also have integration with Open Telemetry, where you can use Grafana and also display what I've shown here. You can also include that in Grafana and use Open Telemetry.
You mean the network graph that you showed us?
Yeah.
Okay.
So yeah, there's multiple work stream in terms of compliance, in terms of visibility, and I think for the next 6 months or something, we're going hard on visibility part with eBPF, and potentially other integration for compliance and syscalls and all those kind of things. But yeah, definitely it's a good lead.
Cool. Thanks. Pini and Chris, do you have any questions for Nick?
Chris?
Yeah, I have one kind of around. Do you think you could extend this product to work on data lineage too? You had that example there where you're querying a SQL database and maybe thoroughly locked down credential, query some data there, and then writes it into another DB that some other workflow is accessing with less restrictive credentials. Could you detect something like that?
Yeah, so today it's really about, we are using the audit log to monitor what calls, what operations are required by the application. And so basically we monitor that. And for every call that we see, we will create the client intent with the right operation. And this is pretty much the current ability. But if we see a new operation, today I don't think we will report it as a new call, right? So that would be if you run like dynamically, because there's a CLI, so you can use it as in pipeline, in whatever you want. If we see a new, like a diff into the operation permissions you need, like updates, is suddenly we monitor that, so we can open automatically a pull request. So we will ask, do you want to allow that? We won't prevent it. We will ask you if you want that, but we always come from the principle that there is a default deny for everything except what is there, and that once you start using authorize, because we are managing and rotating all the credentials, then every application for particular database, every application should use the secrets that, the database can be located anywhere. It doesn't have to run in Kubernetes. It's just the calling application must be in Kubernetes and use the secrets, and where we rotate the username password, so we can control and see everything. This is how we would do it.
Okay. Cool. I'm looking at the time, so it's 1 hour, 22 minutes. I think it's time to conclude, because it's kind of a long live stream, to be honest. So thanks, Pini, thanks, Chris, and thanks, Nick, for spending the time here. I really enjoyed it. I really liked the conversation that we had with Pini. It was really interesting. And Chris, also very inspiring to see the journey that you did at Netflix. And again, for those, I knew Authorize, so for me it was not new, but for those who never heard about Authorize, it's a great product that deserves to be tested, at least, because it simplified a lot of things for us. All right, so thanks, guys, and I will disable the camera and say goodbye to everyone. So see you guys in a few minutes. So for those who've been watching, if you had any questions, the live stream will be available, I think, in most of the platforms. So if you have any questions related to one of the talks, just drop a question, and I will try to forward the questions to the right speaker, and then provide the answer if they don't have the account on the right platform. But again, if you have any questions offline, meaning while watching this recording, just drop it, and we'll try to answer it. If you enjoyed today's content, of course, like usual, don't forget to like and subscribe to the channel, and see you soon for another Observability Lightning Talks. And I remember, for the Christmas edition, in the plan on the 16th of December. So see you on the 16th of December. See you guys.